Hello everyone, hope you're all doing well. Myself Seema Tambe, and the thing which I'm going to discuss today is displacement reaction and double displacement reaction. Okay, so let's start. What is single displacement reaction? Okay, what is single displacement reaction? Okay, so single displacement reaction goes by name. Okay, means one of the reactant is going to get displaced or replace, you can say. What single displacement means? What one of the reactant is going to get displaced. Okay, so what it is basically we'll see now. So what is single displacement reaction? So the reaction where element or metal with high reactivity displaces the element or metal with low reactivity. Okay, what displacement reaction is? The reaction where the element or metal. So now I have written here word metal. Why? Because the element which is going to get displaced, those are basically having the metallic properties. Okay, so the reaction where element or metal with a high reactivity displaces element or metal with a low reactivity. I'll explain you with the help of example. Okay, okay, so what the basic general structure is, this is A, which is a reactant which is highly reactive. Okay, and this is B, which is another reactant which is less reactive. Okay, and this is another one, reactive. Now these are both basically going to get react, and what you're going to get is this is going to get removed. Okay, this is a one reactant, this is another reactant, this is third reactant. So what basically happening over here is, this is element with a high reactivity, this is element with a low reactivity. So the element with a high reactivity is going to remove and takes its place. So I'll explain you with the help of example, you will understand it better. Okay, so the example of a single displacement reaction is, okay, before starting with the example, I'll explain you with, one experiment which is there. Okay, so here what we are taking is copper sulfate solution. Okay, what we are taking is a copper sulfate solution which is blue in color. Okay, what we took is copper sulfate solution, or you can say aqueous solution. So here there is a term. What do you mean by aqueous solution, guys? When you are taking anything, like for example here we are taking is what? Copper sulfate. Okay, so when you're taking copper sulfate and you're dissolving in water, that particular solution which is made out of water, okay, that particular solution is called as aqueous solution. Okay, now what we took is copper sulfate solution, means what? Copper sulfate. Take copper sulfate and dissolve it in, say, 100 ml of water. What solution which you get is copper sulfate solution, which is what? Blue in color. And you dip a iron nail. Okay, and you dip a iron nail into it. Okay, make sure that iron nail is basically new, you can say, or it is polished one. Okay, so what you have taken is copper sulfate solution which is blue in color, and iron nail which is dipped into it. Okay, then keep this for 20 minutes. Okay, keep this for 20 minutes. After 20 minutes, let's see whether there is a change in copper sulfate solution or change in iron nail. Okay, now we'll see whether what observation we get from this experiment. Okay, so this copper sulfate solution we took, and we dipped iron nail into it, and we kept it for 20 minutes. Okay, then what you observed here after doing this experiment, what you observed is, first thing, there is a change in the copper sulfate solution, which was earlier blue, but now it has turned green color. Okay, so what you have observed is change in color. Okay, now that color is changed from blue to green. Okay, and second thing what you have observed is there is a red deposit on the iron nail. Okay, after doing this experiment, two observations which you observed. What is that? First one is change in color, and second one is red deposits on iron nail. Okay, fine. So why is it so? Basically, what is happening over here? What reaction is basically taking place? Okay, now you have seen the experiment, and also you have seen the observation. What? There is a change in the copper sulfate solution. Now it has changed from blue to green, and second thing is what? The red deposits on iron nail. Why is it so? So it is because of the, now I'll explain you with the help of example. Okay, I'll explain you with the help of example what is happening basically in the reaction, and why there is a change in the color, and why there is a red deposit on, you know, nail. Okay, so why is it? Because of the reaction which is taking place, and that reaction is called as single displacement reaction. Okay, what reaction is basically taking place, I'll explain with the help of example. Now what we took is iron nail. Okay, so let's write it iron, which is basically what? Metal, guys, or you can say an element. Okay, and what we took is copper sulfate solution. Now just like I said, copper sulfate solution is aqueous, means what? The copper sulfate is taken and it is dissolved in water. So whatever thing which you get, or whatever solution you get, is aqueous solution. Okay, then you have kept it for some time, the experiment which you see. Now what happened basically? So this Fe is more reactive, guys. What? Fe is more reactive. Okay, so this Fe is more reactive. Copper is less reactive. What? Fe is more reactive. Copper is less reactive. So what iron is going to do? What iron which is more reactive is going to do? That iron is going to remove copper. What? Has iron is more reactive, so iron is going to remove copper from copper sulfate. Okay, and what you're going to get is FeSO4 solution. Okay, what happened basically in the experiment? We took copper sulfate solution, which was what? Blue in color. Then we dipped iron nail, copper sulfate solution. Okay, in which copper is what? Less reactive. Iron, which is more reactive. Okay, now which we took in the form of iron nail. Then what you got is, now as iron is more reactive than copper, so iron is more reactive than copper. So iron removes copper from copper sulfate. Iron removes copper from copper sulfate, and hence you get is what? FeSO4 and Cu, which is FeSO4 is nothing but what? It's a ferrous sulfate, which is what? Green in color. So the solution earlier was what? Blue. It has turned into green because iron have removed copper and it has taken its place. So hence the copper sulfate solution, the ferrous sulfate solution is formed, and hence there is a change in the color. okay, which is green. Fine. What is basically happening in single displacement reaction is the element or the metal, you can say, which is more reactive is going to remove the element or metal with a less reactive, okay, and you're going to get this. Okay, now second example which you're going to see is zinc. Okay, and copper sulfate. So zinc is more reactive than copper. So zinc is going to remove copper and zinc is going to take its place. Okay, third is lead. And we are taking is copper chloride. Okay, so here in this above example, or in this example, what we have seen is the metal or the element which is more reactive is going to replace the element, or it is going to remove the element with a less reactive and is going to take its place. Okay, so see, Fe is more reactive, which is iron is more reactive than copper, so it removes copper and it has taken its place. So we get is what? We get is ferrous sulfate and copper. Now this is what zinc and copper sulfate solution has. Zinc is more reactive, so it is going to remove copper from copper sulfate and is going to take its place. So see, zinc is more reactive than copper, so it has removed copper and take its place. So zinc SO4, okay, which is nothing but what? Zinc sulfate and copper. Third thing is what? It's lead. So lead is also more reactive than copper chloride. Okay, so lead is going to remove copper and take its place. So that's what we get is lead, chloride and copper. Now another thing which is more important is what, guys? Whether it is the reaction is balanced. Okay, so let's see. Fe balanced, Cu balanced, SO4 balanced. So everything is balanced over here. Okay, no need to balance. Zinc done. Cu it's balanced. SO4 it's balanced. Pb which is lead balanced. Cl2 balanced. Cu balanced. Okay, so everything is balanced in this reaction, so we need not to balance anything, okay, because it's already balanced. So what we have seen in this reaction today is single displacement